So, we have started discussing our data networks. So, in that particular thing we have actually talked about how the circuit switch network traditionally changed towards data network. So, there was initiative in DARPA, they started connecting machines and all those things we have already discussed. So, from there what we have understood that the core part of the network probably still requires circuit switch network. We have already discussed why that is required and all those things. And in the access part of this, or where the user is getting interfaced with the network, that is where probably statistical multiplexing is required, and probably a new kind of networking which is the data networks probably, or the packet switch network we should say. So, that is being initialized. So, let us try to understand a little bit more about these kind of networking. Okay. So, what is the requirement and all those things. So, let us try to see in a data network we have already seen that it needs to be done with packets. So, what essentially means that I have a continuous, even if I have continuous streams of data. So, in time let us say it is just initiated over here and it is continuously sending some amount of data. But what I will be eventually doing because of my this packet switch network. So, I will be first dividing the data into smaller chunks, we call them packets. Okay. Or later on you will see that is actually termed as PDU or protocol data unit. So, that why that terms will come to that later. Okay. So, this is where we will be constructing our packets. Okay. So, basically this is the raw data and we have just segregated it into multiple segments. We take those packets and then on that packet we actually add header. These are some redundant bits which are required to fulfill some of the task of delivering the data from one end to another end. Okay. So, this task what is network offering these days. Okay. We have to understand those tasks, how they are linked to these headers, how the header fields are specified, with respect to that how the tasks are being executed. That is what we will be mostly discussing about in this particular part of the course. Okay. So, we need to understand these headers very carefully, but before that we need to understand what is the philosophy of this, what should we do with these headers, what is the task that we are talking about. Okay. So, that is something we need to understand, and we need to also understand the corresponding network. So, these two things. So, network and the associated task. So, these are the two things that we will be mostly discussing. So, the network that we will be building, of course, it should be consistent with the task and the associated task that has to be performed by the network. The major task is only one, deliver the data wherever it is requested, okay, from wherever it is injected and wherever it is requested, faithfully deliver the data. Okay. So, when I say faithfully, there are many parameters of this faithfulness. One is you should not have any drop, another is you should deliver them within some time. So, timely delivery has to be occurring. So, all these things are part of the faithfulness. Sometimes the data order should be maintained. So, all these aspects are the faithful delivery of data. So, all we are targeting, the major task is this faithfully deliver the data, whatever the faithful means to user. So, that is why it is always specified by the user. So, we say quality of experience by the user, QoE, quality of experience of the users. So, data delivery has to cater to this quality of experience that the user are asking for. So, that is all the network has to do. Due to that, network has multiple tasks to perform, because this particular thing to be done, it is not that easy, because there will be millions of users who will be connecting, they will be all asking for same thing. You have to have a common infrastructure and they are all arriving randomly with random amount of traffic. So, you need to handle all these things and you need to deliver faithfully, so that the quality of experience is being satisfied end to end, from wherever the request has come from and up to where the request has to go. So, all these things has to be done. For that we need to design a network properly and we need to see how those tasks can be optimally put forward. So, this is what we will have to see. So, if we now try to concentrate in these two aspects, one is the network aspect and one is the task aspect. So, let us first try to see the network aspect of it and then we will go to the task aspect. Okay. So, what is the network aspect? So, network aspect already we have seen that maybe the whole network does not behave similarly. Okay. So, we have already identified that if the network has access, which is the user interface, and the core part which is the in between. So, basically the core network, this is the core part, and then these are the access which are actually connected to the core, okay, and they require service from one point to another point. So, this core part generally it is a circuit switch network, and this part access part we have seen that it should be packet switch network. So, as we can see that the requirement of network in different location of networking also different. So, therefore, network has to be segregated accordingly. So, what traditionally has been done is that just not access and core, there are some intermediate stages also. So, basically between packet switching and circuit switching there are some intermediate stages also. So, that is how people have segregated the network. So, they call it the access network of course, then the metro network, and then the core or backbone network. Again these also sometimes are segregated. So, this part sometimes there are many names that comes into picture. One is called home access. This is the network within the home. Okay. So, these days even the homes are becoming bigger and there are multiple users who, and there are multiple also envisioned that multiple machines will be there who will be communicating to each other. Your refrigerator will be communicating to probably your microwave and all kinds of things. Your coffee machine will be communicating to the alarm clock. So, all kinds of things will be happening. If that is the case, then within the home also there should be a networking. So, that is the part which is called home access. Then the actual access part, and then the access where it meets the metro, which is called the access metro. Similarly, metro also has two parts, one is towards the access, one is towards the core. So, this is called metro edge and this is metro core. Again core network also it might be regional core, then there might be national core, then there might be international core, even intercontinental. So, there are so many of segments of network, and remember we will later on probably discuss in details that each segment actually does different tasks. When once we go ahead with the task description of the networking, you will see different network segment also actually does different kind of task. That is also another part which will be apparently becoming interesting, and different network segment has varied networking architecture, has varied kind of networking requirement that are over there, what kind of media they used to install, that also vary, because as you can see in backbone the amount of traffic, because they are all getting aggregated. So, the amount of traffic will be very high, whereas access the traffic will be much lower. We have already seen that access traffic is more random, whereas backbone traffic is more smoother. So, therefore, circuit switching probably is more capable over there, but the traffic volume will be very high. So, therefore, optical fiber is probably the only solution. Optical fiber with DWDM means dense WDM technology with very high data rate, sometimes it goes up to each wavelength you go up to 160 Gbps, these kind of transmission, and it also becomes essentially point to point link probably most of the time. So, that is many kind of technological differences will be there, whereas access is more like a common media is there. So, shared media you will be trying to access, everybody is trying to access the shared media. So, there might be chance of data transmitted at the same time. So, either collision or if it is wireless then interference cancellation. So, all kinds of things comes into picture. So, as you can now see, there are a lot of complex tasks which are involved to make the network realizable. So, those tasks we will be also discussing about it, but you can see that the network actually gets segregated along with the geographical location of the network. Okay. So, this is something we will be discussing heavily about each segment of network, what is the specialty of that network, what are the tasks it does, what kind of architecture you need to propose for those kind of network. So, this is one thing that you have to keep in mind. So, that is one part of network. The second part of network which also comes hand in hand is the topology of the network. So, topology means it is like a graph, you have some nodes, and networking is all about how do you propose to connect the graph, okay, or connect these nodes. What should be your underlying edge graph which will connect these nodes. Okay. So, of course, you do not want to leave out nodes, but you also do not want to overdo it. Like in the first or second lecture we have told that if n nodes are there, if everybody has to connect to every other nodes, then NC2 connections are required, and n can be prohibitively large over here in networking. So, it can be some billions of users. So, you cannot really propose to give that many links between users. So, you do not want to do that. So, therefore, there must be some technology. So, the worst technology that we can talk about, or probably we should say that is the in a way best also, because everybody gets connection. So, basically you give connectivity, suppose only these 3 node if we consider, you give connectivity to, or this 4 we consider. So, you give connectivity to everyone. So, all this 4C2, that means 6 connectivity you provide. Okay. So, this is called, this particular network is called graph theoretically it is called click, okay, or in networking term we call it total mesh. Mesh topology. Okay. So, that means everybody should be connected to everybody. So, but this is really not required. So, often we go about it and do something else. Okay. So, there are multiple topologies, like I will list them, later on we will discuss about them. So, you have something called tree, you have bus, you have ring, you have star, you have mesh. Of course, mesh can be total mesh like this one, or it can be partial mesh. So, if we just try to see over here, so let us say I give just 5 nodes over here and I want to connect. So, one might be a tree, that means I go over here to a particular, so basically I construct a tree. So, let us say I go to from this node to this node, from here I probably start branching out, something like this. So, that is a kind of tree network. So, from one particular node I will be going to other branches, from those to other branches. So, I keep doing that. Okay. So, this is a particular tree kind of topology, whereas star is everybody is connected to, I define a central hub kind of thing, and everybody should be given connectivity to that hub. So, that everybody is connected to everybody, and this hub is kind of broadcasting. So, whatever comes to him, he broadcasts to everybody. Okay. So, star network means anybody can reach to everybody. Okay. So, general wireless media, if we have omnidirectional antenna, then it is a star topology, I should say, because I can reach to everybody within the vicinity. Of course, it has to be within the listening range or hearing range, 2 nodes should be within that. If that is the case, then it is a kind of star topology, everybody can connect to everybody, or we can also say that is in a way that is also a mesh topology. Okay. So, we can also term that way. So, that is the star. Ring is you just connect them like a ring. Bus is you connect them like a straight, this one linear connectivity. So, basically bus will just do not have this link. So, if I just connect them these 4 in a linear this one array, then it becomes a bus. Okay. Now, let us try to think about the merit and demerits of these things, and of course, we have also talked about some partial mesh. So, partial mesh means, so suppose I have few nodes. So, I will be connecting few of them to others, not all to all. So, this is kind of partial mesh. So, as you can see, this particular node is not connected to this node directly, but he has via connectivity, and he has multiple such via connectivity. Okay. So, that means he has a option to reach the other nodes in multiple possible ways. Even his neighboring nodes also he can reach in multiple possible ways. Okay. So, that is called partial mesh. That means, I do not provide full or total mesh. So, I do not give everybody to everybody connectivity, but partially I connect them. Okay. So, that is one way of doing it. So, think about this partial mesh and ring topology, it has some inherent advantage. So, these topologies are somewhere means they have some different things. So, we will try to appreciate that part also. So, ring and partial this mesh has some advantage. What is that advantage? The advantage is in network there will be, suppose these links will be failing, there are possibility that links will be failing. It might be just suppose you have a fiber and that fiber gets cut due to road work or due to some other things, due to some natural disaster. So, there is a cut in that. So, immediately what will be happening? So, suppose I have a bus network. So, it is like this, they are connected. Now, everybody was getting connected to everybody else because he can connect to him via these 2 nodes. Okay. So, that was possible. He can connect to this guy via this node. So, everybody was connected in a way, only they have to go and bypass some other nodes to reach the other node. So, connectivity is there, but now suppose I have this link failed, then immediately you can see 2 islands are forming. So, this guy can communicate to this guy and this guy also can communicate to this guy and so on over here. So, they can communicate to each other, but none of them intermediate connectivity is lost. So, none of them from that island A and island B, if we say from A island none of them can connect to B island. This is a big disruption, that one fiber cut that can anytime happen. So, we will have a complete dislocated network and some of the guys cannot reach to others. So, think about that, your important server is residing over here and you are residing over here. You want to access that server, you cannot do that because the network has got a single fiber cut. But if you have a ring or a partial mesh, then you have multiple, in ring at least 2 alternatives are there. So, this guy earlier, suppose he was connecting to this guy over here, now this got lost, you can still come over here. So, ring has an inherent protection. Of course, it comes with a cost, nothing is free over here. As you can see, in ring you need to still put this extra link, which cost, because you will be installing some physical infrastructure over there. You might install fiber, you might install coaxial cable, you might have to put a point to point wireless link, whatever you put, that cost. But with that minimal cost, you are getting some service over here. Partial mesh is even more protected because it has multiple paths from one node to another node to reach. Okay. More actually connectivity you give, more number of paths will be generated and more protected it will be, of course, definitely that is something which is very obvious. So, accordingly you have to design your network. So, now you have understood that the topology is very important, okay, where you are more in failure prone region where the data connectivity is huge, means one link failure means huge amount of connectivity gets lost. So, there you have to provide protection, because more number of, if you go towards backbone, probably one link failure means probably, let us say it's a link between Calcutta and Delhi. So, that link gets failed, that means all the traffic, all the users, millions of users are connecting from Calcutta to Delhi, all their connectivity will be disrupted. Whereas, in your local vicinity one link gets failed, probably the subscriber loop that is directly coming to your home, that is getting disconnected, or that fiber is getting cut, you are the only one who will be suffering, nobody else in the network. Whereas, that particular link, that is carrying thousands of people's traffic. So, therefore, according to the importance of the network, you need to also think about what kind of topology I should put, where I will be having inherent protection. This is something you need to really keep in mind, okay, while designing the network. So, as I was talking about, so you have a network and you have a task. So, this network designing comes heavily with this topology design also. So, what kind of, you have multiple options of topologies, what kind of topology will be taking, that completely depends. Of course, you have options, but you need to now think carefully which one I should put. So, everybody has their pros and cons, like bus has a lower cost of installation, whereas it is not protected against failure. Ring has little higher cost, but it is more protected, at least it has second degree of protection against failure. Whereas partial, this one is more costly, because you have to put some more connectivity, but it is more protected. So, accordingly you have to take a decision. Okay. Again, if you think about this tree also, it is also not fully protected, because one link failure, of course, only one of the guy will be suffering over here, but tree also can be something like this. So, it goes to this, then it goes branches out to multiple other things. Now, where the cut happens, so if the cut happens over here, this entire number of users will be disconnected to this entire number of users. If the cut happens at the lower end of the branches or lower this one levels of tree, then probably not many will be disconnected. So, it all depends. Okay. Sometimes in the upper part of tree you try to provide some mesh connectivity, okay, if possible, because they has to be protected. So, accordingly you decide, actually your topology is your decision, your networking decision. So, you need to decide what kind of topology you should be installing. So, now we have understood that there is regional segregation of network, and also there is differentiation in topology, and you will also see that many of these places have different topology. Most of the times the core you will be seeing, they are more like partial mesh, whereas metro is more like ring, because you need to still give protection. This is more like tree, okay, or bus sometimes, because you need less protection over here. So, you can see also topology basically is decided depending on the kind of network where you are, kind of importance of each link. So, if there is a failure, what to do. So, all those things actually decide what kind of topology will be coming. So, accordingly the network gets segregated, and accordingly you take your decision. Okay. So, that is one thing. Now, after understanding these things, can we now go towards the task of the network? So, let us try to understand what is the task of a network. Let us try to understand that part. So, the gross task we have already understood, that it is just delivering faithfully or delivering with QoE, quality of experience for the users that they have targeted or they have demanded. So, with that you have to deliver the data end to end, from one end to another end, wherever the data has to be delivered. So, that is the major task of networking, but for that task network has to do a lot of things. Let us try to understand this from a very simple analogy that we do often. So, let us say we talk, right. So, this is also one kind of communication. Basically, the entire communication came from keenly observing this particular thing, that our communication, verbal communication, let us say. Okay. So, in our verbal communication, let us try to understand what are the things we do. Can we try to characterize those things? So, whenever we talk, you might be thinking that we can freely talk, but there are some protocols when you are talking to somebody else. What are those protocols, or some rules actually, that both of them should not be, if two persons are trying to make a meaningful conversation, they should not start talking at the same time, they should not be non-talking, or they should not be silent at the same time. That's a basic requirement of communication. So, one should talk, and then when he stops, the other one should start talking, or other one should start responding. So, this is a simple mechanism that if I talk, the other party should not be telling anything, okay, at that point. How do you do that? Generally, whenever there is some gesture, there is some rules of these things. So, you actually initiate a communication, you tell that, okay, can I say something, then the other party gets, he stop talking, he will be listening to you, you start telling, then you can say that I have finished, then the other guy can start initiating, then he can again ask, should I start explaining my own thinking. So, like this it goes on. So, there is a protocol, and if you can see that the protocol is all about, other than talking also you are doing something, some gesture or some verbal phrases also you are exchanging, that wait, can I say something. So, these are not part of actual communication. You might be discussing something about quantum physics, let us say, but in between you are saying something which are not part of that quantum physics. You are just telling others to stop, and then you are trying to say something. Okay. So, this part are part of those almost like header. So, that is where you need to insert some of the extra things to facilitate this communication, and that is the part of protocol actually, where you are adding header to facilitate these things. In communication we do a lot of gestures. So, suppose somebody wants to ask question, what they do? They raise their hand. This is a gesture. Again, it is part of the protocol. It is part of the extra sign communication that you are trying to do to get attention. Okay. Sometimes in a chaotic situation, multiple people are there in a crowd, you want to talk to somebody. So, you just say, shout, attention please, everybody stops, then you talk to him. When you talk to him, you address by his name, then only he will know that it is addressed to him. So, all these things, actually whatever you are talking, that has nothing to do with his name. Probably you are trying to give some instruction that, okay, you should prepare this document, but there you need to call his name because you need to get his attention in particular. You need to give that task delegated to him only. So, this is part of networking again, as you can see, or part of communication task. So, there are extra things. Sometimes you have to do name calling, sometimes you have to do some signing, sometimes in a crowd you have to stop others to communicate by doing some signing. You will see all these things are incorporated in networking. In an access network, if I just give one example, in an access network, everybody, let us say this air, everybody can communicate. If there are 5 fellows over here who wants to communicate to each other, everybody can at the same time can communicate. If they communicate simultaneously, they will collide, because their data will be jumbled up, they will be superimposed and it will become garbage. 1 0 will be all mixed up. Okay. So, if I am doing digital communication, 1 0 will be all mixed up, I will be getting garbage at the receiver end. So, I need to somehow do the mechanism so that somebody can capture the channel. He might say, all others stop, I am communicating, I will finish my communication, then you can start. How do I do this among the machines? So, whatever understanding we had as human being while doing the communication, same understanding has to be given or delegated to the machines, so that they can do the same task. That is part of the networking. That is where we will see a lot of protocols are designed, like all this wireless Wi-Fi you are using or Ethernet protocol you are using. So, all those are coming up with these protocols of collision avoidance, CSMA-CA, CSMA-CD. These are all techniques of accessing the channel, stopping others to communicate, and doing the collision avoidance, so that 2 fellows are not communicating simultaneously and wasting the channel. So, all these things, all these tasks simply taken from human understanding, human communication understanding. Okay. We will try to see and appreciate how this has been implemented, what kind of algorithms has been proposed for these things, how the headers, associated headers, like we have talked about this communication signs or some extra language that we use. Similarly, we have some headers. So, how those headers are consistent with these kind of rules that we will be implementing. So, that is probably the task that we will be targeting in next. Okay. Thank you.